Hello, future engineers. This is level 23, solution 2. I uploaded level 23 to the Trusses part 5, but I found out that there was no pointer, so it's hard for you to understand the explanations there. So I remake this video. So this is the second solution. Remember that uh, FAD was negative 0.4715 of Q. So for the alternate solution, let's show that it is also negative 0.4715 of Q here. But this time the method I apply is method of section, circular section as shown in the figure. So there are three forces involved, FAD, FCF, and FBE. So we make FAD as the unknown to show that it is equal to negative 0.4715 of Q as in the preceding slide. So this is FAD. Then we have FCF and FBE. So remember that FBE makes an angle with the negative x-axis of 75 degrees, and this is 15 degrees below the horizontal. So this, we want to find this point of intersection between the line CF and BE using analytic geometry. So we will call this YF and this distance YD. Because this angle is 45, this YD here is also equal to XD. Imagine that point A is the origin. So therefore, this is, because this is B, equilateral triangle, so B sine of 60 is square root of 3B over 2. Square root of 3 over 2. Therefore, the coordinates of point B would be B over 2, half of this one, B over 2, because this is the origin, and square root of 3, B over 2. So this is the point slope form of equation of line. Y minus y1 equals slope of the line quantity x minus x1, where the slope of the line is the tangent of the angle it makes with the positive x-axis, counterclockwise positive. Or if it is clockwise, then make the angle negative, tangent of the negative angle. Remember from trigonometry. Because this is 75 degrees, the angle that line BE makes with the positive x-axis is 180 minus 75. So it is 105 degrees, tangent of 105. But it is also negative 75 if you make the measurement clockwise. So here I use negative 75 instead of tangent 105. But they are the same. So cosine from this right triangle, cosine of 15 degrees is B over 2 over distance CF, where distance CF is also distance AD. So distance CF equals distance AD equals 0.5176 of B. So knowing that this is 0.5176 of B and this angle is 45 degrees, then we can now solve YD, which is equal to XD because the angle is 45. Remember the opposite and adjacent sides of 45 degrees are equal. So sine 45 degrees is YD over distance AD, which is also 0.5176B. So YD is equal to 0.366 of B, which is also XD as shown. So this is also 0.366 of B. So we now find the equation of line BE. Again, we use square root of 3 over 2 as Y1 and B over 2 as X1. So Y minus square root of 3 over 2B equals tangent of negative 75 degrees or tangent of 105, it's up to you, X minus B over 2. So simplifying, Y minus 0.866B equals negative 3.732X then plus 1.866. Tangent of negative 75 times negative B over 2 is 1.866B. Simplifying, 3.732x plus y equals 2.732b. Call that equation 1. Next, line CF. So the angle that line CF makes with the positive x-axis is 180 minus 15, 165, or it makes an angle below the x-axis of 15 degrees, so negative 15 degrees. Instead of tangent 165, I use tangent of negative 15 as slope of line CF. So y, this coordinate C here is b comma 0, because A is the origin, so that's b, then y is 0. So y minus 0 equals tangent of negative 15 degrees times quantity x minus b. Simplifying, y equals negative 0.2679x plus 0.2679b. Then 0.2679x plus y equals 0.2679b. So let's eliminate y by subtracting equation 2 from equation 1. So 3.732x minus 0.2679x is 3.41x, then 2.732b minus 0.2679b is 2.4641b. From here, we can now solve x, which is xg, and it is equal to 0.7113b. As shown in the figure, that's 0.7113b. Then substitute in equation 1 to solve for yg. Yg is positive but very small. So 3.732 of 0.7113b plus yg equals 2.732b from equation 1. So yg is 0.0774b, which is this. So that's 0.07743b. So that we can have the moment arm. Remember that this is also 45 degrees. So we set moment at G0. Then there are two components of FAD, horizontal and vertical. The horizontal and vertical components are both counterclockwise about G. So moment about G counterclockwise is positive. Then there are two forces that must be involved, FAD and the Q, load Q. So for the horizontal component, so this moment G equals 0 equals FAD sine of 45. Then the moment arm is YD minus YG, this vertical distance here, YD minus YG. This is YD, this is YG. So I hope you understood the moment arm. This vertical distance of D from G is YD minus YG. Then the vertical component is counterclockwise also. This is equal to FAD cosine 45, and the moment arm is XG 0.7113b minus 0.366b. So plus FAD cosine of 45 degrees quantity 0.7113b minus 0.366b. I hope you followed. You can follow. Then finally plus Q, which is also counterclockwise, times quantity xg 0.7113b minus b over 2 or 0.5b. So that's the equation. So combining FADs, there are two terms. 0 for your ease of calculation, 0.4482 FADB. Then this Q here, 0.7113 minus 0.5 is of course 0.2113 QB. Cancel out B, so we can now solve FAD negative 0.2113 Q over 0.4482. And it must be close to this so that we will stop. So it's close, or they are almost equal. Therefore, that's the end, because the following solution would be the same as in solution 1. So therefore, FHC is 0.4296Q as in before. So the solution after this is the same. We isolate joint A, then set summation versus vertical to solve for FAB before summation versus horizontal to solve for FAC. So this is now the details, because I have now the pointer, and hope you follow the solution.